Hello everyone, my name is Richard Jiang and I'm a technical marketing engineer here at Cisco's Wireless Enterprise Networking Business Unit. I'd like to welcome you to episode 2 of a 4-part series on the Cisco Aironet Active Sensor. In today's episode, I'll be going over the deployment details regarding the Aironet Active Sensor. First, I'll be starting off with a deployment workflow in which I'll be providing you with an end-to-end view regarding how we can go from initially mounting the physical sensors in your office to running the wireless tests on Cisco DNA Assurance. Next, I'll follow it up with an in-depth explanation and demo regarding how the sensor communicates and gets provisioned to Cisco DNA Center. Lastly, after the sensor has been successfully provisioned to Cisco DNA Center, I'll finish it off with a demo regarding the ways we can manage our sensor settings. To get started, let's jump right into the high-level sensor deployment workflow. The sensor deployment workflow is broken down into 3 main steps. Starting off with day 0 is sensor deployment and provisioning, in which the sensor will be mounted at their physical location, optimal for testing the desired wireless networks. However, prior to mounting the sensor, we first need to plan how we would like the sensor to communicate with Cisco DNA Center, which is required for sensor management. This is broken down into 2 options, a wired or wireless backhaul. Depending on the option selected, it'll determine how your sensor is physically mounted and the modules that would be equipped with your sensor. Upon successfully mounting the sensor, once the device receives power and an IP address, the sensor will then initiate a workflow known as plug and play, in which the sensor will automatically reach out to your Cisco DNA Center. On the Cisco DNA Center, you'll now have the ability to claim and provision the device, allowing it to be officially managed by the application. You'll now have the ability to place the sensor onto your sitemap for a heat map and neighboring AP view, and at this point, your sensor has been successfully provisioned. Now that our sensors have been successfully provisioned into Cisco DNA Center, we can now optionally manage the devices through this application, such as upgrading the device, changing its name, editing the SSH settings, and many others. Upon completing this step, we've now arrived to day 1, in which we will be creating the test templates that will determine the different tests that we would like our Aironet Active Sensors to run. This includes categories such as onboarding, throughput, application reachability, and many more. We can then deploy and execute these test templates to either all sensors within a specific location or individual sensors depending on the goals of your testing. After our tests have begun executing, this brings us to day 2 and onwards, where we can now sit back and begin monitoring our sensor test results. This can be done through Cisco DNA Center, where we can view the aggregated results of all provisioned sensors on our sensor dashboard, or the individual sensor results through our Sensor 360 page. Now that you have a high-level understanding of how we would go from initially mounting the sensors to finally assessing the health of your wireless network, let's take a step back and begin discussing in details how we can provision the sensor to Cisco DNA Center. As discussed earlier, we'll first need to determine the method in which we would like our sensor to communicate with Cisco DNA Center. The first method is through a wired backhaul, in which we would attach a PoE module to the sensor. Then, through a regular Ethernet wire, connect the sensor to a switch that has a configured DHCP server as well as a configured VLAN to provide reachability to the Cisco DNA Center. Through the switch, the sensor will now have received both power and an IP address. For the second method, we have the wireless backhaul, in which we'll be enabling a sensor provisioning SSID with the default name of Cisco Sensor Provisioning on our wireless LAN controller. Upon enabling this predefined and hidden SSID, our APs will begin broadcasting it, allowing our sensors to automatically join and receive an IP address. Since the sensor receives an IP address wirelessly rather than wired, we technically only need power from the wired source. So in addition to the PoE module that we had been using earlier, we now also have the option to power the device through a module that supports a micro USB Type-B connector or a module that supports a direct AC power. As a disclaimer, please keep in mind that the IP address provided to the sensor must come from a DHCP server in order for the backhaul communication to work properly. Before moving on, let's jump into a quick demo to show you how the Cisco Sensor Provisioning SSID is enabled on the controller for the wireless backhaul method. Starting off with the AirOS controller, navigate to Management, Cloud Services, Sensor, then Enable Provisioning. At this point, navigate to WLANs and you can confirm that a Cisco sensor provisioning SSID has been generated successfully. The same can be done with an iOS 6E controller. Within the search bar to the left, type in Cloud Services, click on Cloud Services, then enable provisioning. Then, within the search bar, type in WLANs, click on WLANs, and you can confirm that a Cisco sensor provisioning SSID has been generated successfully here as well. Now that we have a thorough understanding regarding how a sensor would communicate with Cisco DNA Center, let's dive into the different methods that will allow a sensor to discover Cisco DNA Center in the first place. The way the Aironet Active Sensor discovers Cisco DNA Center is through a built-in agent called Plug and Play. The first method of Plug and Play is called the DHCP option 43 discovery, in which all we need to do is include this string within your DHCP server. The sensor's built-in agent will then reach out to the DHCP server, decipher the string, and use the information included to reach out to Cisco DNA Center. If you look closely, this string includes information such as the IP address and the port number. For our second method of Plug and Play, we have DNS discovery, and this method will automatically initiate if the option 43 discovery method fails. To use this method, all we need to do is include a DNS server IP address within the DHCP pool, then within the DNS server, create a forward entry of PMP server which points to the Cisco DNA Center's IP address. The sensor's built-in agent will know to initiate a DNS lookup to the PMP server entry, and will discover Cisco DNA Center like that. Now, if for whatever reason you're unable to use these plug-and-play methods, there is also a last resort manual method that can be used, which is through our sensor's command line interface. The command line interface of the sensor can either be accessed through its console port, which would require a special console cable dongle to be attached to the back of the device, or through SSH. Just as an FYI, the device by default will leave the SSH port open during day 0 provisioning, but after it's claimed to Cisco DNA Center, it will be disabled and will require you to manually enable it. We'll discuss this in detail later in the video. Upon entering in the command line interface of the sensor, all you would need to do is enter the following command and specify the IP address of your Cisco DNA Center. At this point, through one of these three methods, your sensor should now have reached out to Cisco DNA Center and appeared on the Plug and Play page. Let's take a look at how we would complete the sensor provisioning workflow on Cisco DNA Center through a demo. When we initially log into Cisco DNA Center, we'll end up at this home page. Now, as a prerequisite for claiming the sensor, we need to make sure that we have sites that depict the physical location of your office building defined within the network hierarchy page. We can navigate to this page by opening the menu, clicking Design, then Network Hierarchy. As you can see here, I already have a number of sites defined where my devices such as my wireless LAN controller and APs reside. If you're new to this portion of the workflow, you can go ahead and click on the gear icon, and it'll allow you to create either an area or building under the global level, or a floor within the building level. Within the floor, you can also include a floor map, which will provide you with the ability to place your APs and sensors directly onto this map for a heat map view. For the purpose of this demo, let's just stick with the sites I've already created. To claim a sensor to your site, open the menu, click on Provision, then Plug and Play. Here, you'll notice that all your sensors that have reached out to Cisco DNA Center through the methods described earlier will be listed here with their state as unclaimed and their onboarding state at 40%. To claim any of the sensors, click on the checkbox next to the device, hover your cursor over Action, then hit Claim. At this point, you'll have the option to change the name of the sensor if so desired. Then, select the site that depicts where your sensor has been deployed in real life, then hit Next. Here, we can choose our sensor configuration by clicking on Assigned, then choosing the predefined Cisco sensor provisioning profile. In regards to the wireless backhauls, this profile will determine the SSID that the sensor uses to communicate with Cisco DNA Center after being claimed, and as best practice, it's recommended to keep it as default. However, if you'd like to choose a different SSID to use for the wireless backhaul communication, there is an option to edit this. You can do so by navigating to the sensor management page by opening the menu, clicking on Assurance, then Sensors. Now, hover your cursor over the settings, click on Backhaul Settings. Now go ahead and click on Add Backhaul to configure a custom backhaul SSID you'd like your sensor to use instead. For the purpose of this demo, we'll stick with the recommended practice of using the default predefined backhaul profile. Go ahead and click Save, then Next to complete the screen. And wait for your day 0 config on the right to turn from a blue loading circle to a green check, then hit Claim. At this point, you've completed the manual aspect of the claim workflow. Your Cisco DNA Center is now exchanging information with the sensor in order to establish a communication for management. And once this communication has been successfully established, the state will change to provisioned and the onboarding state will change into a green check. Now that our sensor is officially managed by Cisco DNA Center, we have one more step to go through before managing its settings, and that would be placing the sensors onto a physical location within the floor map. Let's navigate back to the network hierarchy page and to the floor that we've claimed our sensor to. On the top, click on Edit. Then on the right next to Sensor, click on Position. At this point, you'll notice sensor icons appear on the right-hand side, and you can actually drag these icons directly onto the floor map. After placing the icons in the areas of the floor map that most accurately depicts where the sensors actually are in real life, click on Save, and now you're officially done with the sensor provisioning workflow. Now that our sensor is managed on Cisco DNA Center, we can now configure and execute everything through our Cisco DNA Center graphical user interface. Let's quickly go over what sensor-related settings we can manage. The first thing is image upgrade. The sensor you've deployed may not be running the latest version, and Cisco DNA Center allows you to upgrade all your sensors easily at once. To do so, navigate to the image repository page by opening the menu, clicking on Design, then Image Repository. Here, navigate to the site your sensor is provisioned on. Here at the top, the version column will inform you of the image you've selected as your device's primary image. And if you haven't manually selected a primary image prior, it'll show you the version your devices are currently on. By clicking on the arrow to the left of the sensor's product ID, it'll expand the list and show you all available sensor software releases listed on Cisco CCO. To import one of these images, we can go ahead and click on the star next to the image version we want to upgrade to. Let's go ahead and mark software release 211 as the golden image. Confirm you want this to begin importing from Cisco CCO and wait for it to complete. Once this is completed, navigate back to the inventory page by opening the menu, clicking Provision, then Inventory. Now, you can go ahead and select the sensors you'd like to upgrade. Hover your cursor over Actions, then Software Image, then click on Update Image. In step 1 of this image update workflow, we can configure when we would like this image upgrade to take place. You'll have an option to either upgrade the image now or select a time in the future by creating a task. Since the devices that you've selected could be in a physical location that has a different time zone than yourself, leaving that site's settings enabled would run this task based on the time zone of that site. Otherwise, uncheck it to manually set a time zone. Let's go ahead and configure this workflow to upgrade our devices now, then click on Next. In step 2 of this image update workflow, we can configure when we would like the image we're distributing to the sensor to be activated. To provide insight, if we only distribute the image but don't choose to immediately activate it, the new image will just sit within the sensor storage. Only when it's activated will the sensor switch over to the new software image. Similar to before, we can either choose to activate the image immediately after distribution completes, or at a time configured in the future. Let's go ahead and have our sensor image be activated right after the distribution is completed by clicking here at the top, then Next. At this point, we've reached step 3 and the final step of the update image workflow, where we can now review our configured distribution and activation settings, and then confirm the update. If you've chosen to distribute and activate the image right now, the sensor will immediately download the image, reload, and then join right back. As you can see, my sensors are now software version 2.1.1. Moving on, the second sensor setting we can manage is editing the name of the sensors. If you didn't have a chance to do so in the claim process, you can still edit this by navigating to the sensor management page by opening the menu, clicking on Assurance, then Sensors. Here in the list, I'm noticing one of the sensors has a misspelled name that must have happened by accident during the plug-and-play claim. All I need to do to fix this is select the sensor in question, hover my cursor over actions, then click Edit Sensor Names. But let's take this one step further. I want to organize my sensor names so it's clear which sensors belong to which site. At the top, I'm going to sort my sensor list by location. Now, I can select the sensors that belong to the San Francisco site. Hover my cursor over actions, then click Edit Sensor Names. I can then choose a name for my sensors and click Save. Notice, in addition to the sensor's name being changed to the name I've chosen, sequential numbers have also been appended to the end of each sensor for differentiation reasons. We can now easily tell which sensors are from what site from just the name. The third sensor setting we can manage is the LED light that by default constantly flashes on your physical sensor device. If you'd like to disable this LED light from flashing, you can select the targeted sensors, hover your cursor over actions, click on the Edit LED option, switch it off, then click Save. The fourth thing we can manage is enabling the SSH on the sensors. As designed, the sensor SSH would become disabled after plug-and-play claim, but we can manually enable it again. We can do so by selecting a target sensor, hovering your cursor over actions, then clicking on Edit SSH. Here, we can enable SSH and enter both a username and password for logging into the sensor. Now, one of the ways to retrieve the sensor's IP address to SSH into it is by clicking on those three vertical dots at the top right of the table, which will open up a table menu. Select the IP address option, and now a column labeled IP address will appear. Using this IP address, we can now open up our terminal and SSH to the sensor using our defined SSH credentials. Now, why don't we try running a command or two? Let's start off by running the show.11 sensor stats command. This command will provide information regarding the different statistics related to the sensor's connection with Cisco DNA Assurance. Another useful command is the show.11 sensor synthetic work list command. Although in this series we have yet to configure and deploy a test template to sensors, if done so, this command would show the details for each of the tests that were executed as well as relevant metrics such as the name, result, time, and many more. As you can see, if your sensor is having any issues, SSHing into the device and running some show commands can provide some insight as to what's going on. For a more detailed breakdown of the available sensor commands, please view the sensor deployment guide linked within the description below. The last sensor setting we can manage is enrolling the sensor to a SCEP profile. If you're not familiar with what SCEP is, it stands for Simple Certificate Enrollment Protocol, and at a high level, allows network devices to easily enroll for a certificate by using a URL and a one-time password to communicate with the public key infrastructure. The advantage of SCEP is that it has the potential to save administrators time by speeding up the device certificate enrollment process by making it automatic as opposed to its usual manual process. To create a SCEP profile, within the Sensors Management page, hover your cursor over Settings, then click on SCEP Profile. Then to the right, click on Add SCEP Profile. Here, you would be able to enter your details of your SCEP profile and then click Save. For the purpose of this demo, I've already created a SCEP profile by the name of Sensor SCEP Profile, as you can see here. In order to enroll my sensors to this profile, I can navigate back to the sensors list by clicking on the Sensors List tab on the left. Then, I can select the sensor that I want to enroll, hover my cursor over Actions, and click Enroll using SCEP. Here, I can select the SCEP profile I've created prior and click Save to complete the workflow. With that being said, this concludes episode 2 of the Sensor series. In the next episode, I'll be going over the different categories of tests that we can configure and deploy on the Aironet Active Sensor in day 1. To view this video, please click on the link in the description below, and as always, thank you for watching.